Deep within the realm of physics lies a fascinating phenomenon called sonoluminescence, where sound waves can mysteriously transform into bursts of light. When powerful sound waves pass through a liquid, they can create and trap tiny bubbles in a process called acoustic cavitation. These bubbles undergo an incredible transformation as they rapidly collapse, compressing the gas inside to temperatures hotter than the surface of the sun. Scientists use specialized equipment to create stable sonoluminescence, where a single bubble can produce continuous flashes of light thousands of times per second. During collapse, the bubble's contents are compressed so violently that temperatures can reach 20,000 Kelvin, causing the gas inside to emit a brief flash of light. The intensity and color of sonoluminescence can vary depending on the liquid used and the dissolved gases present in the solution. When multiple bubbles undergo sonoluminescence simultaneously, they create a mesmerizing display of thousands of tiny light flashes, like underwater stars. This remarkable phenomenon continues to intrigue scientists who are exploring its potential applications in fields ranging from medical imaging to clean energy production. Sonoluminescence stands as a testament to the incredible ways energy can be transformed, turning sound into light through the power of tiny bubbles.